Kia ora, Year 10. In this video I'm going to go over how we draw the graph when we're given the equation, and I'm going to use the intercept gradient method. So if you're watching this video, you need to first of all have an understanding of how we find the gradient on a graph and what the gradient means. Okay, and you also need to understand what the y-intercept is. So I'm going to go over those very quickly, but I'm basically going to assume you've got that. So let's look at how we would draw the graphs of these four equations to start us off. So let's take the first one and just identify what information is coming out of that equation. Well, the first thing we know is that that plus 2 on the end is the y-intercept. So that tells me that when x is 0, y is 2. Now I can see that if I take this equation and I substitute 0 in for my x value. Right, so y is equal to 3 times 0 plus 2, which gives me 2. When we're drawing the equation of a graph, it's really easy if we've got it in this form, because the first thing we can plot is this point here, which is 0, 2. So I'm going to go now over to a blank GeoGebra grid, and we're going to have a go at it. So I can put the y-intercept on here at 2. Let's have a look now at what the gradient tells us. Well, the gradient in this equation is 3. The gradient, which we write as m, is equal to the rise over the run. So when you're starting out with this method, I find it useful sometimes to think of that 3 as 3 over 1. And that tells me that for this graph, if I go out 1, then I have to go up 3. And that gives me my second point to plot. And that's all we have to do, right? We've got an equation of a straight line, so 2 points is enough to make that work. Now it's fine to draw a third point, and that can make your graph slightly more accurate. But 2 points is all we really need. Okay, so that's the first one done. Let's go back and have a look at the other equations. So you'll notice that I've done something here on purpose to emphasize how the gradient affects the graph. I've made the y-intercept 2 for all four of these lines. But the gradient is different for each of them. So let's look at the second one. We've got y equals 1/3 x plus 2. So again, we're going to start with putting on the y-intercept, which is at 2. I'll change it to a pink blob this time. This time, the gradient says go out 3, 1, 2, 3, and then go up 1. Take your ruler, join up the 2 points. Now you should notice, just from looking, that this makes sense with what we know about gradients of graphs, because this one here has got a gradient of 3, so it's a really steep positive gradient, whereas this one over here, 1/3, is still a positive gradient, but it's a much flatter line. The next equation that we had to do is this one. Y equals negative 1/3 x plus 2. So again, we can start with the y-intercept at 2, and we go out 3, right? 1, 2, 3, but now we go down 1, and we join up those 2 points. And the last of the lines, just give ourselves a bit of room, is this one. Y equals negative 3x plus 2. You should be getting to the point where you can start to visualize these lines before you draw them. So the y-intercept is 2, and the gradient is negative 3. We can write that as negative 3 over 1. We go out 1, and this time we go down 3. 1, 2, 3 to here. We grab the ruler and we join up the points. Okay, I know that some of you are probably going to stop watching soon because this is really boring, but I'm going to do 2 more sets of these, and what I'd like you to do is, now that you've got the hang of it, pause the video, use your maths book and try them first before I go through them. You really have to practice this to make it easy. So that's the nice version that you can pause on for the first batch of graphs. Okay. Now, here are the 4 steps that we're going to follow every time. We're going to find the y-intercept, and we draw a blob at that point. Then we find the gradient, and we write it as a fraction. And we remember that we go out, and then we either go up or down, and then we join up those 2 points, and we've got our line. Okay, so here are the next batch of graphs that I'm going to do. I recommend that you do those 3 on one grid, and then the next 4 on a separate grid. So pause the video here, try and draw them, and then come back and go through what they look like. Right, well, the first one, y equals x minus 2. This has got a gradient in it of 1, okay, invisible 1. We never write 1x, but we can think about it as 1 or 1 divided by 1. So here I'm starting with my y-intercept of negative 2, down here, and then I'm going out 1, up 1. Right, so we can join up those 2 points and we rule them up. When the points are pretty close together, it can be worth drawing a third point just to make sure you're being really accurate. You can see if you look closely here, I've gone a tiny bit off here, which isn't brilliant, but it'll do for now. Right, the next one, y equals negative x minus 1, has a y-intercept of negative 1, and the gradient here is negative 1. So we go out 1 and down 1. Grab the ruler and join the dots. The next one is y equals negative a half x plus 1. So we start at the y-intercept, it's here, and then the gradient is negative 1/2, so I go out 2 and then down 1, grab the ruler and join the 2 dots. I've done another blank set of grids for the next graphs. Oh, there we are. That's the first 3 there. Actually, I haven't. I'm just going to remove all of these and we'll do the last ones. I suspect there's no one still watching at this point, but hopefully that's because you know what you're doing now. Right, if anyone is still watching, I will bring a chocolate fish to school once we're back. So you just have to send me an email and tell me that you got this far through the video. And maybe you also have to send me a photo of your graphs. So these are the ones we've got left to do. Now I've done these because I've found that people sometimes have trouble with fractional gradients if you don't think about what's going on in the gradient. Okay, so all of these graphs have got a y-intercept of +1. That means that every one of them is going to go through this point here. But what happens after that depends on the gradient. So if the gradient is 4/7, that means that we go out 7 to here, and then we go up 4. So this is going to get me a nice accurate line, especially if I get rid of this in the way there. Take the ruler, join up the points. Whoop! It wasn't meant to happen. Okay, now no one is watching. There's my blob and there's my line. Okay, the next one. The gradient now is 7 divided by 4. So this time, this might not fit on my graph actually, we start at +1 because of the y-intercept, and we go out 4 to here, and then we go up 7. Now up 7 is going to be off my graph. So that's not very good. What can I do instead of that? Well, in real life I probably would have enough graph room that I could do it, but I can always substitute a point in here and plot that point. So in this case, what could we do? Well, we could substitute in x equals 2. This is not the normal method here, but this is what I'm going to make the next video about. So let's see what we get here. Now this is going to make it even worse. Let's see. If we put 2 in here, we're going to get 14 over 4. My brain's going very slowly today, guys. I think it's the end of lockdown happening. Right, so that gets me to 4.5. So when x is 2, we'll have this point here. It would be nice if we could just go all the way out with out 4 and then up 7. And that's hopefully what you're doing in your maths book. Right? So you can see that's a much steeper line because the gradient's bigger. Right? The gradient is 7 over 4. Okay, 2 left to do. I've got 5 minutes left till I run out of time anyway. So the next one has got a negative gradient. Y equals negative 4/7 x plus 1. So again, we start with the y-intercept of plus 1. Here it is. And we go out 7. 1, 2, 3, 4, 5, 6, 7 to here. And then this time we go down 4 units. 1, 2, 3, and I've gone off the scale again. Okay, it wasn't very well planned, this video, was it? I made my numbers a bit big. Right, there we go there. So that's that line. And the last one is negative 7/4x plus 1. So same idea. I'm going to show you the graphs done in GeoGebra, and you can check your work against them. So there we go. You can see that these two here, this one is the one with a gradient of 7/4, and this is the one with the gradient of negative 7/4. Alright, thanks for watching. Just going to recap one more time. What's the method that we're using here? Well, it's the gradient-intercept method. The first thing we do is we plot the y-intercept, and then we use the gradient to go out and then up or down. I'm going to do another video shortly where you have to rearrange the equation before you get it into y equals mx plus c form.